So, how do we build a robot? Let's start at the beginning. The first step of building a robot is the design. Beginning in the off-season and continuing after kickoff, we trained members on how to use Fusion 360, an instrumental tool in our design process. We use Fusion not only to model the structure of our robot, but also to prototype, visualizing the path of the ball through different subsystems of the robot and calculating trajectories of shots. While our mentors are an amazing resource, we take pride in being a student-led team, designing the robot ourselves. During these design meetings, we keep detailed notes, records, and logs for future reference. Now that we have a design, it's time for manufacturing. In the past few years, we've transitioned from hand tools and tedious measuring to a CNC-focused workflow. Ideal for its unmatched precision and reliability, CAM training has allowed us to create components we couldn't before. This year, nearly every part of our robot passed through the CNC or lathe. During this manufacturing process, new members gained experience on all of the tools in our build room, including the CNC, lathe, drop saw, manual mill, vertical bandsaw, and hand tools. Even though we designed everything carefully in CAD beforehand, we still found ways to improve our design, and went through several design iterations for each component. The next vital component of any robot is electrical. Our amazing electrical sub-team begins training new members in the off-season to ensure a speedy transition to manufacturing. Members are trained through rotations and learn all about soldering, crimping, and maintenance. Also during the off-season, we keep a detailed inventory of electronics and pneumatics components, such as motors, motor controllers, and pistons. This year, we created an electrical board mounted to the bottom of the robot, allowing for easy repairs and a clutter-free top. This is where our programming team comes in. Members are trained in Java and the robot's code early in the year. Then, they're divided into groups to develop code for specific mechanisms. To maintain an efficient workflow, the code stays largely the same each year, with the programming team focusing on small improvements and developing autonomous and mechanism-specific code. We never miss an opportunity to improve our programming knowledge, so this year, we took on projects such as using a PID feedback loop in order to maintain consistent shots on the goal. Sensors and cameras are also used to help with the autonomous period and driver vision. The drive to learn and improve is felt by all of our members and reflected in our team's spirit, energy, and passion.